Now let's do this next one here, number 7. So because 2 is a 0, that means I know I'm going to have x minus 2 as a factor. Since I have 2I as a factor, that means I know x minus 2I is going to be a factor. Now because I have 2I, then I know I'm also going to have a negative 2I, which means then that x plus 2I is going to be another factor. And that's from the complex conjugate theorem. And then the next one here, I'm actually going to do it this way. If this 4 minus the square root of 6 is a factor, that means I know x minus that, 4 minus the square root of 6, is a factor. And then it's also going to be 4 plus the square root of 6 is also going to be a solution. So then x minus 4 plus square root of 6. Okay, so it's a little bit longer. Yes. Is it too hard to figure out? No, we'll be able to do that just fine. So I'm going to multiply these two together because it's going to work out nicely. It's going to give me x squared plus 2xi minus 2xi. And then last is going to be minus 4i squared, right? But then those two go to 0, and remember I squared equals negative 1, so this comes out to be x squared plus 4. I'm going to bring this one down here, x minus 2. Now this is going to be x minus 4 plus root 6. This is going to be x minus 4 minus root 6. So to multiply these two, I'm going to do everything in the first one times everyone in the second one. It's going to give me an x squared minus 4x minus x root 6. And this one minus 4x plus 16 plus 4 root 6. And this one plus x root 6. This times this. I'll come down here. Minus 4 root 6. This times this. Minus square root of 6 times 6, which is 36. Now it seems really long, but if you start noticing, there's a few things that will reduce with each other. So right here I have a negative x root 6, and I have a positive x root 6. So those will go to 0 together. And then same thing with this one, 4 root 6, and this is a minus 4 root 6, so those go to 0. I can combine this one and this one. So this right here is going to be just x squared. Those two together is going to give me minus 8x. This right here is the same thing as minus 6. And then I have that 16. So it's going to be plus 10. Remember, I also have that x squared plus 4 and the x minus 2. So we're getting there. Let's keep going here. Let's FOIL these first two here. So this is going to give me x cubed plus 4x, inner minus 2x squared, last minus 8. I'm just going to put those in order. X cubed minus 2x squared plus 4x minus 8 times that x squared minus 8x plus 10. Alright, let's see if we can put this in here. Alright, so x cubed times that's going to give me x to the 5th minus 8x to the 4th plus 10x cubed. This times this is going to give me minus 2x to the 4th plus 16x cubed minus 20x squared. This times this, 4x cubes minus 32x squared. This times this plus 40x. And then this times this minus 8x squared plus 64x minus 80. Kind of running out of room, so I'm going to come up here to the left and write this all up. So I just have 1x to the 5th. That's right here. Combining these two together gives me negative 10x to the 4th. These three is going to be 2630 x cubed. These are all negatives, so it's going to be 40, 50, 60 minus 60x squared plus 104x minus 80. And I know I kind of squeezed that in there, but you get the idea of that one. Alright, this is Descartes' rule of signs. It says let f of x equal this function. This is just a generic way of saying some polynomial. Be a polynomial with real coefficients. The number of positive real zeros of f of x is equal to the number of changes in the signs of the coefficients f of x, or is less than this by an even number. And the negatives is if same scenario if you plug in negative f of x. So it says determine the positive numbers, number of positive real solutions and negative real solutions and imaginary zeros for the function. So on this one we know that the total is going to be 3. So let's look at the number of sign changes here. So this is a positive, this is a positive, and this is a negative. So we only have one sign change here. So then positive real zeros would just simply be 1. To figure out negative, we're going to need to figure out what f of negative x is equal to. So negative f of x is equal to negative x cubed minus 2x minus 11. So notice they're all 3 minus, so there's no sign changes. So that means there's going to be no negative solutions. Now remember, imaginary, because that, remember, it says also imaginary zeros. Imaginaries come in pairs. There either is 2, 4, 6, 8, or 10. Since our total number is going to be 3, there's one positive. That means there's going to be 2 imaginary. So let's do this next one here. Sign changes, positive to negative. This is positive to negative, so that's 1. Negative to positive, that's 1. Positive to negative, that's 1. Negative to positive, that's 1. So that means it's going to be 4, 2, or 0, because, or less than that by an even number. So all the even, subtract 2 from that, subtract 2 from that, subtract 2 from that. Then we'll need to plug in and find out what g of negative x is equal to. Now this negative x to the 4th, since it's to 4th power, it's just going to come out to be that 2x to the 4th still, because it's an even number. This one's going to change the sign, so it's going to be plus 8x cubed, because again it's an odd number. This one's going to come out to be positive still, so it's going to be plus 6x squared, because again, even exponent, it's going to be plus 3x plus 1. So notice there's no sign changes, all of them are positive, which means that there will not be any negative real zero. So then when we're talking about imaginary, we know they have to come in even numbers. So there's either going to be 0 if there's 4 up here. There's going to be 2 if there's 2 up here, or there's going to be 4 if there's 0 up here. Notice your homework down here if you haven't already. Pause it, read that yourself. Good luck, guys.